Oh, we're going now. All right. So this is called congruent shortcuts. Uh-oh. There we go. All right. All kinds of technical difficulties here. So this is called triangle congruent shortcuts. So let me look in my notes over there. I have to look at the right notes. So if you have two triangles that are congruent, okay? So say I have, here's triangle A, B, C, and say that triangle ABC is congruent to triangle DEF. What does that mean? If I say triangle ABC is congruent to triangle DEF, what does that mean? Equal what and what? Size and shape, right? And if they're congruent, that means that every single piece is congruent. So side AB is congruent to DE, right? And side BC is congruent to which side? EF. And AC is congruent to DF, right? And what else is congruent? The angles, right? So angle A would have to be congruent to angle A. Angle E would have to be angle E. B would have to be congruent to angle E. And angle C would have to be congruent to angle F, right? And so if I'm working at the triangle making factory, you know, and I say I want to make a triangle exactly like triangle ABC. How many different parts of each? How many different parts does each of these triangles have? How many parts does it have? It has three sides and it has three angles, right? So is it enough to just know that three of the sides of this triangle are congruent to three? If I want to make a triangle exactly like this one, right? Can I just take three sticks that are the same length as this and make this triangle? Or do I need to copy the angles too? You need to copy the angles too? I don't know. Or do I just need to know two sticks and an angle between them, right? Or do I just need to know the angles? Or do I just need to know two sides and then an angle, right? So those are called triangle congruence shortcuts, because once you know that these triangle shortcuts work, and the possibilities are, so the first possibility I gave you is called side, side, side. This thing, you'll get to this in a minute. We'll write them all down at the end, okay? But we have a possibility of side, 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 okay? Then we have a possibility of side, angle, side, where the angle is called an included angle. An included, which means, okay, it's between the two sides. So if you have a triangle like this, okay, where I tell you here's side A, B, or triangle ABC, angle A is included between sides AB and AC. Do you understand what that means? The angle is between the two sides. Then we have a non-included angle. Okay? So one possibility is side, side, side. One possibility is side, angle, side. Another possibility is, what if I know an angle, a side, and an angle? If I know that this angle is congruent to this angle, this side is congruent to this side, this angle is congruent to this angle, is that enough to show that those triangles are congruent? What do you think? Yeah, I don't know. Okay? We're going to explore that. What about angle, angle, angle? What if these three angles are congruent to those three angles? I don't know. You can play with it. Okay? We're going to play with it. Another possibility is angle, angle side, okay? So this is a, see, there's angle, side, angle, angle, side, angle. Angle, angle, side would look like this. An angle, then an angle, then a side. You guys understand the difference? Angle, side, angle, the side has to come in between the two angles, okay? So we're going to explore, and the other possibility is two sides and an angle, okay? Side, side, angle. We don't call that angle, side, side for obvious reasons because spell bad word. We call it side, side, angle, okay? So, side, side, angle would look like side. So if this side with one mark is congruent to this side with one mark, and this side with 2 marks is congruent to this side with 2 marks, and this angle with 3 marks is congruent to that angle with 3 marks, that would be a side, and an angle. A side, and an angle. Is this a way to say that everything else has to be congruent? You understand what we're getting at? So these are very traditional, that I've been learning them since I was in high school. Possibilities for are these triangles congruent? So I found this nice exploration, okay, where you can drag things around. I didn't make it up. I wrote up the worksheet to go with it. I'm going to pause for a second here while I give you that. Here it comes. So you go to this like hyperlink. Where'd that just go? And you click on this. It says the directions on there. And you click on View Book. And I want you to do it in the order that I showed you. So I asked you to do this one first, angle, angle, and then angle, angle, side. Let's just look at this one, angle, angle, side. So they're all kind of little mini investigations. So with angle, angle, side, so this is the figure that kind of controls everything. So what they did is they constructed this triangle over here, and they constructed these pieces of a triangle such that this angle is always going to be fixed with this angle. So this angle and this angle are going to always be congruent. And this, see how this is 72.8 and this is 72.8? That's always going to be congruent as well. And if it's angle, angle, side, this side that is 6 is always going to be equal to this side, right? So it's going to go an angle, and side. Notice if I drag it, okay, those two pieces, this is changed, right? But it's still the same as this. And this is the same as this, right? And this side is 7.7 and that side is 7.7. So what you are going to try to do in most of these investigations is try to make a triangle out of the right side, okay? And so I'm going to try to drag, and there's only, based on the restrictions that these right figures are built on, you can only really make, you can only really manipulate them in certain directions. So how can I make a triangle out of this? These angles have to stay the same, right? So something's going to have to change here. So, oh, see, that side could change. So you have to kind of drag around and see what things can change and what things can't. And then I'm going to try to make a triangle out of this, okay? And then you look at your two triangles, and do those triangles appear to be congruent? Okay? Yes. So then what I ask you to do within all these investigations is drag this, right, and see if I move this around, if I change things, are they still congruent? Well, that's what you're going to determine, okay? So you're going to walk through and you're going to see. So I have all the things that I listed on the board there. I have, did I start recording again? I don't remember. I don't remember. There it is. Oh, there it is. Yeah, I'm still recording. So, where'd my GeoGebra go? Oh, come on. Where is it? Not here, not there. Is this it? There it is. Okay. No. So, no. So you are going to go through these various explorations, and some of them work. There's some of them that work, and some of them that don't work, right? And you guys are going to go through and see which ones you can only make one triangle out of the right side. You get it? Okay. So if angle is a way to prove that triangles are congruent, it should really be angle. Because if two angles of a triangle are the same, What has to be true about the third angle? If one angle is 60 and one angle is 50, what's got to be true about that third angle in both cases? It's got to be the same, right? So angle, angle is really the same as angle, 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 right? Okay, so you're going to work through those, and you can work with your partner, you can work by yourself. I don't care if you want another sheet. If you want to work by yourself, I have it up here. But go through and explore those and answer the questions as you go, okay? And then we'll talk about them a little bit, all right? Okay, so probably about, I don't think it should take more than 20 minutes or so, okay? And you don't need to be in GeoGebra. I think it automatically loads it in for you, but you will need a computer or a tablet or something like that. So here's the side-side angle exploration. So when I'm doing this one, if I move this side, so notice that...
We can't see what you're doing.
Oh, I have it on freeze. I'm sorry. Okay. There. Okay. So if I have this triangle right here, right, and even if I change this triangle right here, the way this one is set up is such that this side is congruent to this side, right? And this side is congruent to the side that is 13. See the 10 on mine and the 13? And if I drag those two sides, now it's 11 and 14. See that? Hello? Okay. So that's side, and then the angle that is fixed, which is the fixed angle on this one? That this angle that is 33, okay? This angle that is 33 is always going to stay 33. So I have this 8. Oh, I have the 8, the 15, and this angle. So that's side, then a non-included angle. See it? Side, non-included angle. Side, non-included angle. I could draw a triangle this way, okay? Does that triangle look exactly the same as that triangle? No, okay? But I could also draw a triangle if I move this over here and I slide this one. How does it work? I think this one I could go like this. Wait. Oh, here we go. There's one triangle I can make. There's one triangle. This one does not look like that one, right? I can make another triangle by moving this back to here and that over there. See, this one looks more like that. Does this one look like that?
No.
Oh, that one does not look like that. But the other one does look like that, right? This one, everything is the same, right? 8, 15. If it was exactly lined up, what's exactly lined up? Should be 4, 8, 15. Is it exactly the same? I can move that. Let me try again. Make this. Move that. This can go. See, this side could go here, like this. These triangles look the same. 20, 13, 18, is that right? 20, 30, no. Those triangles don't look the same. But I can make a triangle given those parts. This triangle here, whoa, what happened? I can't change that. I can, I get one triangle here, and then I can make another triangle like here. These aren't that much different, but here's one triangle, here's the other triangle that looks the same, basically. 20, 13, 14, why aren't those things changing? But in any case, you should have discovered that side-side angle does not work. Yes? No? Maybe? It's kind of hard to see with this. Let me see if I make it obtuse. very obtuse. Here, look at this. Does this triangle look the same as this? Almost? No? Yes? Maybe? It should look the same. Those don't look the same? Not even close. How about this one? Ah, there we go. Here we go. See this triangle has a, oh, I know what I'm doing wrong. I'm looking at that. This triangle is the same as that triangle, right? 11, 12, 20.
Yeah.
130 degree, basically 24 there, 24 there. This angle over here is 26, right? But if I drag this out here and move this over here like this, I think your triangle has to be obtuse in order for it to work. So this still has a side that is 12, 12, a side that is 20 and 20, right? And an angle that in both cases is 26, right? See the 12, 12, 12, 12, 20, 20, 26, 26. But is this triangle congruent to that triangle? Are those two triangles congruent? No. So side angle does not work as a way to prove triangles are congruent. So that's kind of what we're getting at. Okay? So I don't know how effective that was. Maybe it was okay. But so getting back to my, I think I want to go through these couple things. Okay? So take some notes for a few more minutes. You could finish up that investigation, writing it up. But out of my 6 possibilities, angle, 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 does angle, angle, angle work? Yes or no? No. Okay. Side, side, side.
Yes.
Yes. So if I had 3 sticks of one triangle and 3 sticks of another one, that one works. Side, angle, side. Can I make more than one triangle
No.
given that? So this works. Okay. How about angle, side, angle? Does that work? Yes, that works. Angle, angle, side.
Yeah.
That works as well. Side, side, angle. Did that work? No. Okay. So out of the 1, 2, 3, 4, 5, 6 different possibilities, the only 2 things that don't work are angle, 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 and side, side, angles. So, Jack, put your phone away, okay? I want to do some examples, okay? So say I have a picture that looks like what if I were to draw, let me get my freehand shape tool, where is it? Tool, freehand shape. So I have a picture that looks like this. That's not, oh, that's a bad picture. And I do something like this. And I tell you, even though it doesn't look correct, I tell you that this angle is congruent to this angle. This angle is congruent to this angle. This angle here is congruent to this. Okay? Is triangle 1 congruent to triangle 2? Is 1 congruent to 2? Yes or no? Why?
Angle side.
Yes, angle, side, angle. A lot of times, see the side? Where's the side, Ian?
It's one in the middle.
Very good, okay? This side is in both triangles, right? So angle, side, angle, angle, side, angle. So yes, by angle, side, angle. This is going to be like what your homework's going to look like. So this would be a good idea to kind of pay attention to this, okay? How about if I had a shape that looks, got that? Maybe you should write some of these down. Yes, maybe no. I think these are good examples, or at least pay close attention. I'm going to do another one. What if I had, go ahead, I'll pause. Wow, some of you I know want to write that. Is it angle, angle, side? Where's the angles?
It's on the middle line.
That's a side, right?
Yeah, but the middle line, the two angles on both sides are because of the
This is
parallel line.
congruent, right?
Yeah, that's congruent to
This is congruent to which one?
the one on the right on the top.
That one's congruent to that one, right? And what else is congruent?
The other angles. Like,
No, not
that
necessarily.
one. The
right?
one to the right on the bottom and the one to the left on the top.
This one?
Yeah.
Not necessarily. Because this means congruent, it doesn't mean parallel, right? So this angle is not necessarily congruent to that angle, right? But how about what other side is in both triangles? What side is in both of those triangles? BC, right? So I have a side, right? I have a side, and then I have a non-included angle. See that? Side, side, not included angle. Are these triangles congruent?
No.
No. Because it would be side, side angle. You get that? Yes, sir.
DCA is the triangle.
Oh, I meant DCB. I'm sorry. Thank you. DCB. Okay. Thanks. Okay, but so you have to be really careful with that, right? Because this would be a side, then a side, then an angle, and a side, then a side, and an angle. If the angle were in between, then they would be okay, but the angle is not in between. Okay, what if I'm given this picture? There's another one. Freehand shaped tool. So they like to give you this picture a lot. This comes up a lot. Okay. And I'm going to tell you in this one that this is congruent to this. This one, that's congruent to this. And that's all I'm going to give you. And I'm going to ask you A, B, C, D, E, C. Is triangle ABC congruent to triangle DEC? Yes or no? Is there something I know about an angle that's congruent in both of them? Which one? Is it angle, side angle? Where's another angle that, yep, where's the other angle? Ryan? They're very good. See this? Vertical angles are always congruent, right? See the vertical angle?
Yeah.
Vertical angles are always congruent, so I have a side, angle, angle. Side, angle, 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 side, it's the same, right? Side, two angles, right? So yes, by, side, angle, angle, or you could call that AAS, right? You understand what I just did there? Yeah, no, okay. Couple more. We'll do, let's just do one more, and then we'll be done. What if I had something like, oh, this is a good one. And shape. I gotta get that freehand shape onto my freehand shape. What if I did this? And then I did this. And then kind of like that. I did this. Okay. And I said that and I say this, okay? GF given GF is congruent to HE, and F, this is an F, FH is congruent, that's an H, FH is congruent to EG, is triangle GFH congruent to triangle HEG. HEG. Why? So again, look at those triangles. Here we have some overlapping triangles. Who can tell me if this triangle here is congruent to this triangle here? You're given these two things, right? Given this. You're given that this piece is congruent to this piece, and this whole segment is congruent to this whole segment here, right? This piece. So you're given this is congruent to this is congruent to this is congruent to this is congruent to this. And I want to know, is this triangle congruent to this triangle? Why, Trevor?
Well, because they share the bottom side.
Very good. Okay. They share side GH. See that? See, they share that side. They have that. So GH, yes, they have GH in common. So what would that be? Side, side, side. Okay. You get it? So there. I mean, you have to look at the picture, see which ones you're given. Make sure that the three pieces you have are ones that work, right? So if you have side, side, angle, that doesn't work. If you have three angles, that doesn't work. But any of the others, angle, side, angle, side, angle, side. But you also have to use what you learned previously, like vertical angles, sharing sides, alternate interior angles. You have to use that stuff to try to make your deductive argument. And then after we learn about one more thing, then we start getting into doing these actual proofs. Okay, so I'm done. You can work on that investigation. You have about finish that up, or if you're done with that, you can just turn.